Hello everyone and welcome to the channel. We are all obsessed with one question in this market. What is the next Nvidia? It's the question that drives conference calls, that fills investing forums, and that probably keeps a lot of us up at night. But I'm going to tell you right now, that is the wrong question. The trillion-yen-dollar question isn't what's the next Nvidia, it's what is the next TSMC. Why? Because Nvidia, AMD, Google, Amazon, they are all designers, they are architects, but they don't build anything. The company that physically manufactures the future, the one with a foundry, the one that turns silicon wafers into intelligence, that's the company that holds the keys to the kingdom. TSMC, or Taiwan Semiconductor Manufacturing Company, has become one of the most valuable and strategically important companies on Earth because it has a near-gen monopoly on building the most advanced chips. If you want an Nvidia H-Noon, you have to go through TSMC. But the AI revolution is creating a new problem, a new bottleneck. The nature of chip manufacturing is changing so fundamentally that a new kind of builder is about to become just as critical, just as dominant as TSMC is today. The title of this video is not clickbait. I believe there is a little gen-known stock flying almost completely under the radar of mainstream finance that is on a path to build a critical part of all AI chips by Liantian Censure. And no, it's not another foundry, it's not Intel, it's not Samsung, and it's not a secret new startup. It's a company that solves the single biggest physical constraint holding back the AI industry right now. A constraint that Nvidia itself has admitted is its primary bottleneck. Today, we are doing a deep dive into the case for why this company could be the TSMC of the next decade. To understand this opportunity, you first have to understand the problem. AI chips are not like the computer chip in your laptop for decades. The game was simple. Follow Moore's law. Shrink the transistors. Go from Gen nanometer to Gen nanometer to C to Wu to Sen. Smaller transistors mean more processing power in the same space. TSMC is the king of this, but AI, especially large language models, broke this model. The problem with AI isn't just processing speed, it's memory. Models like GPT-4c are so enormous that the biggest challenge is simply feeding the processor with data fast enough. The processor is constantly starved, waiting for data. This is called the memory wall. The solution the industry came up with is brilliant. It's called HBM, or high bandwidth memory. Instead of placing memory chips next to the processor on the circuit board, they started stacking them vertically. They stack bar or shard DRAM chips on top of each other, creating a Sendy skyscraper of memory that sits right next to the processor, allowing for a massive high-gen speed data connection. Every single Nvidia H-Noon, H-Noon, and AMD's M-Noon X uses HBM, but this creates a new, massive engineering problem. You now have a giant GPU processor, which is itself getting so big it's being broken into smaller chiplets, and you have these tall stacks of HBM. How do you connect them all? You can't just use a normal circuit board. The connections need to be microscopic, incredibly dense, and perfect. The solution is called advanced packaging, specifically a technology pioneered by TSMC called CoWoS, or chip gen-on-gen wafer gen-on-gen substrate. Think of it as a mini ultra-gen premium circuit board called an interposer. The giant GPU chiplets and the HBM stacks are all placed on this interposer, which contains thousands of microscopic connections linking them all together. This is the bottleneck, not the Gen nanometer chips. Nvidia has said publicly that their only constraint on HE/S supply is not TSMC's chip gen making capacity, but its CoWoS packaging capacity. TSMC can't build these mini-gen interposers fast enough. The entire AI industry is being gated by this one obscure step in the manufacturing process. So, the investment thesis is simple. The company that provides the essential, irreplaceable tools to solve this advanced packaging bottleneck. Not just for TSMC, but for Intel, Samsung, and everyone else will become the new choke point. They will become the TSMC of packaging. The company I believe is poised to do this is Kaliki Face Software, ticker symbol KGenL-GenI-GenC. Now, if you've been investing in semis for a while, you might be thinking, Kaliki Face Software, aren't they? That old boring company that makes wire bonders, and you'd be right. For decades, Click has been the market leader in wire bonding. That's the old way of connecting chips, literally using microscopic gold or copper wires. It's a cyclical, low-gen growth, legacy business. But that is precisely why the market is missing this story. Click is in the middle of a profound transformation. They are using their cash cow legacy business to fund a pivot into the single most important growth market in semiconductors advanced packaging. While the world is obsessed with wire bonding, Click has been pouring its RFID into a next-gen generation technology called TCB, or thermal compression bonding. Let's break that down. The old way of attaching chips, called mass reflow, is like baking. You put tiny balls of solder on all the connection points, put the chip on top, and heat the whole thing in an oven until the solder melts, making all the connections at once. It's cheap, but it's messy. The solder balls can melt and flatten, and you can only place the connections so far apart. It's not precise enough for HBM or chiplets. TCB, or thermal compression bonding, is completely different. It's a tool that picks up a chip, aligns it with pinpoint accuracy, and then uses a heated bond head to apply precise force and heat only to that chip. It bonds the thousands of micro-gen bumps, teeny copper pillars to the interposer substrate with surgical precision. Why is this a game changer? 3 reasons. First, precision TCB allows for a much finer pitch fade, the distance between connections. This is the key to connecting HBM and chiplets, which require tens of thousands of connections in a tiny space. Second, SEND stacking. TCB is the enabling technology for stacking chips on top of each other. You can't put a chip that's already been stacked through an oven again. TCB allows for a sequential layer, gen by gen, layer assembly process. Third, it's the future. The entire industry from TSMC's CoWoS to Intel's Foveros to Samsung's iGen Cube is moving toward TCB for high-gen performance applications. Kaliki Software has developed a suite of TCB tools like their Catalyst and Apama series that are specifically designed for this high-gen performance computing and AI market. They are moving from being the king of wires to being the king of bonds. Now, if you're finding this level of deep gen dive analysis valuable and you're tired of hearing the same surface gen level hype about the same 5 stocks, do me a favor and hit that subscribe button. We go deep here every single week, and smashing the like button really helps tell the algorithm that this is the kind of thoughtful, in gen depth content that serious investors actually need. It helps us cut through the noise. So the thesis is that Click is providing the next generation of picks and shovels for the AI gold rush. But this is where it gets even more interesting. The story doesn't even end with TCB. TCB is the bridge to the ultimate technology, which is called hybrid bonding. This is the holy grail. Hybrid bonding is where you bond 2 chips together with direct copper, gen-to-gen copper connections. No solder, no micro-gen bumps, just pure copper. This would allow for connections that are 10 times denser than even TCB, enabling truly SEND chips that function as a single piece of silicon. The bandwidth would be astronomical, and guess who is a leader in developing the tools for hybrid bonding? Kaliki Software. They call it their Project W, and they are working hand-in glove with the major foundries and research institutes to perfect this technology. This isn't just an idea, it's the industry's confirmed roadmap. This is why the title says, by Liao Chenin censure. This is not an overnight trade. This is a long-term technological shift. Today, now the market still looks at Click as an old Jan World Wire bonder company. Its stock price moves with the cyclical semiconductor industry. When PC and smartphone sales are down, the market sells Click, even though its legacy business is becoming less relevant to its future. The market is pricing this like a Yichen Jilbajilshas hardware company, not a Liao Chenin Sensemes AI enabler. This is the opportunity. The market is mistaking a profound secular growth story, the rise of AI and advanced packaging, for a temporary cyclical upswing. By Liancheng in Senshu, the entire landscape will look different. Monolithic chips for AI will be a thing of the past. Everything high-gen performance will be a system of chiplets. Every AI processor, every TPU, every advanced GPU will be built using heterogeneous integration, and the demand for advanced bonding tools, TCB, and eventually hybrid bonding will not be cyclical. It will be permanent, foundational, and non-gen negotiable. The company that provides these tools will be in an identical position to ASML today. ASML is the only company in the world that makes the EUV lithography machines needed to print Wugen nanometer and Shenzhen nanometer chips. TSMC, Intel, and Samsung must buy from ASML. They have no choice. This gives ASML incredible pricing power and a massive, unassailable moat. By Liancheng in Senshu, Kulicke Face-Offer has a clear path to becoming the ASML of assembly. They will provide the critical TCB and hybrid bonding tools that all foundries and OSATs, the outsourced assembly and test companies like Amkor and ASIS, must buy to build AI chips. When NVIDIA wants to build its Liancheng in Senshu Gen era GPU, it will go to TSMC, and TSMC will build those chips using ASML's lithography machines and Kulicke Face-Offer's bonding machines. CLIC will be an essential non-gen negotiable linchpin in the entire global supply chain. They won't just be a supplier, they will be the supplier for the most critical step in physically assembling intelligence. When that happens, this will no longer be a Wu or Liu billion-dollar company. This will be a Wuxi, Barsha, or even Yalding billion-dollar company, valued not as a cyclical toolmaker, but as a strategic enabler of the entire AI economy. Now, as your expert guide, I have to be responsible. This is not a risk-free bet. You cannot have this kind of upside without significant, serious risks, and you need to understand them first. And most obviously is competition. CLIC is not the only company that sees this. Their main competitors are B Semiconductor or BSI out of Europe and ASM Pacific Technology ASAMP. This is a 3-gen horse race. BSI in particular is a very strong competitor in TCB. The risk is that TSMC or Intel chooses BSI or ASPT as their tool of gen record for their next gen factories, and CLIC gets locked out. This is a technology race, and the winner will take most of the market. My thesis rests on CLIC's RFID, their deep customer relationships from their legacy business, and the performance of their tools. But it is a race. Second, this is still a semiconductor capital equipment company. This entire sector is brutally cyclical. If we hit a major global recession in Liancheng in Arshilil, AI spending will slow, data center build-outs will pause, and the demand for all tools will plummet, including CLIC's. This stock could get cut in half before the long-gen term thesis ever plays out. You need the stomach to hold through that volatility. This is a Wu-gen to Fu Qi-gen year hold, not a Wu-gen month trade. Third, there's technology risk. What if a new disruptive technology emerges that bypasses bonding altogether? For example, what if optical interconnects using light instead of copper to communicate between chips becomes viable and cheap faster than anyone expects? That could make TCB and hybrid bonding obsolete. This is a more distant risk, but it's real. Fourth, customer concentration. The entire market is just a handful of buyers, TSMC, Intel, Samsung, and a few big OSATs. If any one of them decides to go with a competitor, it's a massive blow to revenue. This gives the buyers a lot of power to negotiate on price. So let's be crystal clear. This is not financial advice. This is a high-gen risk, high-gen reward, speculative, long-gen term thesis. You must do your own research. This is an idea for the patient, research-gen-oriented investor who is willing to take a concentrated position on a specific technological outcome. But the thesis, to me, is one of the most compelling in the entire market. To summarize it all, the AI revolution is gated by a manufacturing bottleneck. That bottleneck is no longer shrinking transistors, it's advanced packaging. The core technology for advanced packaging is moving from mass reflow to thermal compression bonding and ultimately to hybrid bonding. Kulicke Face-Offer is a boring legacy company that is using its cash flow to become the dominant provider of the essential tools for this new bonding era. The market is valuing them as a cyclical, old-gen tech company. The opportunity is to buy them before the market realizes they are about to become a secular, high-gen growth, strategic enabler for the entire AI industry. By Lianchenin censure, every AI chip made by every company will likely have to pass through a bonding tool. The company that makes that tool will be the next TSMC. That's my analysis. I've laid out the entire case, from the technological problem to the specific solution, and the company I believe will win. Now, I want to hear from you. This supply chain is incredibly complex, and I know many of you do your own deep gen dive research. What other little gen known companies in the AI supply chain are on your radar? Are you looking at materials companies, testing and metrology plays, or other obscure picks and shovels that the market is ignoring? Drop your thoughts, your own research, and your counter-gen arguments in the comments below. Let's build this community knowledge base together. Thank you for your time. I'll see you in the next one.